This is a question I borrowed from IB past paper, and they are asking you to calculate activation energy for this reaction. Now, if you go to data booklet, which they are asking you to do so, you find natural log of K is equal to minus EA over RT plus natural log of A, your frequency constant. And if you look at the plot, it's already plotted for you. The y is natural log of k, and your x is 1 over t. Now, in order to calculate EAs, I'm looking for the slope, so I pick and choose 2 points that are easier to read. This point here versus this. So this is my sort of triangle. And then I have the 2 points, and I simply calculate slope. Meaning this is my first point, this is x1, y1, and x is 1.4. Don't forget the exponent, it's times 10 to minus 3. That's how your 1 over Kelvin is usually. And your y is simply minus 5, no units. This is the second point, so this is x2, y2. X is simply between 1.7 and 1.8, so it's 1.75. times 10 to minus 3. Your y is between 10 and 15. That's negative 12.5. So let's calculate slope. Slope is simply rise over run. So y2 minus y1 over x2 minus x1. So in this case is minus 12.5 minus a minus 5 divided by 1.75. This time I take exponent outside, minus 1.4 times 10 to minus 3. So when we do this, slope becomes equal to minus 21,428. Now the slope is simply minus EA over R. So this is the slope part of it. And your x is 1 over t. So the slope is equal to minus EA over r. If you have a number for it, which we just calculate, simply if you are calculating EA, it's equal to slope multiplied by minus r. So let's do that. So EA is equal to minus 21,428 times R, which is gas constant, 8.314. So when we do this, I get 178,157 joules per mole. Usually we report it in kilojoules, so divide by 1,000, so it's 178.2 kilojoule per mole. So that's your activation energy. If you are being challenged to calculate your A or frequency, you could extrapolate and go here and sort of read it from the graph, what it is, or you can calculate it. I'm going to calculate it. So to calculate that, I'm going to say natural log of K is minus EA over RT plus natural log of A, and I'm going to take this point here. So minus 5, which is natural log of K, is equal to minus EA that I calculate. I'm going to use the joules. Minus 178,157 divided by R, which is 8.314, multiplied by temperature. Now don't forget the temperature should be 1 over this. If 1 over T is equal to 1.4 times 10 to minus 3, the temperature is 1 over that, which is 714 Kelvin. So 714 plus natural log of A. If you do this calculation carefully, you have minus 5 is equal to minus 30 plus natural log of A. So natural log of A is simply 25. Now if you take the exponent, if you take e to power 25, that's where you find your a, and that is, when I calculated, it's 7.2 times 10 to minus, sorry, 10 to power 10. That's a. And natural log of a is simply 25.